Today, I want to present about project 2 induction motor test. We are from group 4. My name is Mohammad Falina bin Jafar and have Haziq Hasbi and Nur Rabia. Next, I want to the introduction. In this experiment, we will learn how to determine circuit model parameter of the three-phase induction motor. A three-phase induction motor is a electromagnetic energy convert that transform three-phase electrical input power into the mechanical power at the output. A three-phase induction motor consists of the structure and the rotor. It was the name three-phase inductor because of the fact that the rotor current is induced by the magnetic field instead of the electrical connection. Okay, test first. We can do a DC test of the three-phase induction motor. Test 2, block rotor test of the three-phase. Test 3, no load test of the three-phase induction motor. And the last one, the test 4, simulation torque speed characteristic of the three-phase induction.
Assalamualaikum. My name is Mohammad bin Osman. I will continue present for the test 1, which is test of the three-phase induction motor. So as you know, a three-phase induction motor is an electromechanical energy conversion device which convert three-phase input electrical power into output mechanical power. A three-phase induction motor consists of a stator and rotor. So first of all, we present for the circuit which is we develop using MATLAB software. So this is the circuit that we developed by using the MATLAB software. First of all, we're using a synchronous machine SI unit, which is the synchronous unit machine. So for our group, we have to change the squirrel cage preset model for 50 horsepower, 460 volt, 60 Hz and 1780 RPM. So this is the preset model that we get from the lecturer that have been given. So for apply, okay. From this step we have to get the result for IDC and the VDC. So we have to run first of all by follow the instruction. We have to run the model for 10 seconds and record the result of IDC and VDC. So change the stop time to 10 seconds and run the circuit. So this is the simulation of the circuit. As you can see, the value of the IDC that we get is 35.27 ampere, and for the VDC is 5 volt. Based on the instruction, after we get the result, we have to calculate the value of the stator resistor, which is R1. So this is the result that we get. For the calculation, the value of the stator resistor, we use the formula in VDC over 2 times IDC, which is 5 volt over 5 volt over 2 times 25.27 ampere. So the answer for the calculation that we get is 0.0989 ohms for the R1. So the next part is for the test 2, which is block rotor test of three-phase induction motor. As you know, the block rotor test enable us to determine the efficiency and the circuit parameter of the equivalent circuit of a three-phase induction motor. in the blocker rotor test, the shaft of the motor is locked so that it cannot rotate and the rotor winding is short circuit. So this is the circuit that we developed. So just same for the previous circuit. We use the same squirrel cage preset model, which is 4, and the mechanical input is speed. And then based on the structure, we have to raise the Vmax from 1 to 5 volt and run the model for 10 seconds. So we have to run the model, change the stop time to 10 seconds. Run the model. So this is the summation of the circuit. As you know, we have to change the Vmax from here, which is 1 to 5 volt. So 1 will scale by 2. So the change 1 until 5. So this is 2, 3, 4, 5. So that's all you have to change. And then this is the result that we get for the BPH, IPH and PSC. So from the information, this is the table 2. We have the data from 3-phase induction motor for block motor test. And so this is the Vmax that we have to raise 1 until 5, which is for the 1 volt. For the I we get is 1.796 ampere, and for the PSC we get 2.242, and for the ISN and volt 220 volt we get 395.12 ampere. For the power factor we get 1.567 milli, and for the RLR we get 0.8725 milliohm, and for the SLR we get 0.5568, and for the PCU stator we get 0.416 watt, and for the PCU motor we get 1.826 watt. And the next is 2 volt. For the 2 volt we get the current is 3.591 ampere, and for the PSC we get 8.968, and for the ISN we get 395.01801 ampere, and for the power factor we get 3.1345 milli, and for the RLR we get 1.746 milli, and for the XLR we get 0.5569 ohm, and for the PCO stator we get 3.8535 watt, and the PCO rotor we get 5.1145, and then for the next is 3 volt. We get for the current is 5.386 ampere, and for the PSC we get 20.17, and for the ISL we get 394.97 ampere, and for the power factor we get 4.003 milli, and for the RNR we get 2.6181 milliohm, and for the SLR we get 0.5569 ohm, and for the PCU stator we get 8.6688 watt, and for the PCU motor we get 11.5012 watt, And then for the 4 volt, for the current we get 7.186 ampere, and for the PSC we get 35.88, and for the ISM we get 395.23 ampere, and for the power factor we get 6.2668 milli, and for the RLR we get 3.4883 milliohm, and for the SLR we get 0.5566 ohm, and for the PCO stator we get 50.4312 watt, and for the PCO rotor we get 20.4488 watt, and then the last is 5 volt. We get for the current is 8.979 ampere, and for the PSC we get 56.06, and for the IXN at voltage 220 volt we get 35.076 ampere, and for the power factor we get 7.8362 milli, and for the RLR we get 4.364 milliohm, and for the SLR we get 0.5568 ohm, and for the PCU stator we get 35.0924 watt, and for the PC rotor we get 31.87 watt, and for the average of the ISN we get 4.3876 ampere, and for the average of power factor we get 4.70096 milli, and for the RLR average we get 2.61778 milli ohm, and for the SLR average we get 0.5568 ohm. And then this is the calculation that we make. So from this calculation we use the formula for the ISN is current time 230 volt divided by V phase, and for the power factor which is cos theta, and for the ZLR is V phase divided by I phase, and the RLR formula is ZLR cos theta, and for the SLR formula is ZLR sin theta, and for the PCS theta formula is 3 times by I and power of 2 and times by R1, and for the PCU rotor is PSC minus PCU stator. So this is the calculation. So same as the 4 volt 1, just you have to change the value of voltage. So right here, so this is the formula of the average for the average ISN, power factor, and average RLR, and the average for SLR. The next part is we have to calculate the value of the equivalent resistor, which is R equivalent equal to R1 plus R2. So this is the formula by using the R2 value of R1 calculated in the DC test. So this is the formula. So R2 equal to R equivalent minus by R1. So 2.61778 milliohm minus by 0.09961. So the answer is that we get for the R2 is negative 0.09699 ohm. The next is we have to calculate the value of the equivalent reactor, which is S equivalent equal to S1 plus S2. So this is the formula. So, first of all, we have to assume the S1 is the S2. So the calculation is SR1 equal to 2 times S1. So S1 equal to SLR divided by 2. So 0.5568 divided by 2. So the S1 that we get is 0.2784. So this is the calculation that we get for the S1. So that's all from me. Thank you.
Rahim. I will present about test 3. Okay. First of all, we from group 4. We must set a block parameter to 0.4, actually 50 horsepower, 460 volt, and 60 hertz with 1780 RPM. Okay, and then we mechanical input we must to click the torque and reference frame to auto. Okay, apply and okay. First, we must set this for this equation. 400 multiplied by SQRT multiply 2 divided by SQRT divide multiply 3. Okay, and then we use 50 hertz, and then we can run to get the V V I and P in. Okay, uh, set the consists of the 400, and then dot with 0.04 50 hertz 50 hertz, and then okay we must run. Okay, we must make sure to stop time is we must 20. Okay, to get the right. uh, Okay, you can see after done run, you can see V line is 380. Okay, we must plus, and then to VTH V total we can get plus all this 300 401 415 ni divide by 3, and to get the VTH same to IPH we must total it and divide by 3 to get the IVTH. Okay, for this you can see P in 3.241, PSC equal to P in. That's all for test 3. Continue with the test 4. Okay, first of all we must make sure this block parameter set the 0.4 with the horsepower 460 volt 60 hertz and 780 to RPM because we are from group 4. Okay, and then mechanical input we must set to speed. Okay, and reference frame is state rotor. Apply. Okay, all of this seems to test 3. Okay, for this we want to see the graph to take the height reading. Okay, first we must run this simulation. After done run this simulation, you can see VTH we can get when to total this reading and divide by 3 to get VTH, and same to IPH we call total it and divide by 3 to get the total. Okay, for this we can see the graph. Okay, this part we want to see the graph. Okay, after get this we must take the proper view. Okay, take this and click uh, to get the highest reading. Okay, what is okay. Okay, we can see we can get 1344.25. Okay, we can we see when we see we must take the highest point for this graph. Okay, we can see 1344.25 and 745.84. The T is 14.08. Okay, that's all for test 4 the motor. Okay, lastly, the conclusion for this project. In this conclusion, a machine that exchanges mechanical energy into the electrical energy is an electrical machine. Many industries use electrical machine, including power plants, electric car, and residential appliance. More, Moreover, even though they do not convert mechanical energy into electrical energy, transform the exchange alternating current AC from the one's voltage level to another are also regarded as the current electrician machine. The purpose of the test in the motor routine test is to conclude power factor. Starting and the test normally is done at lower voltage and result of the test extrapolate to the rate voltage. The majority of the mechanics prefer to use multi-purpose robot instead of the human employee in the present period as need as the expectation keep rising right since robots are quicker and more efficient than human. That's all for my team.